Hey there, myself Krishaiduk, and very warm welcome to all, and very warm welcome to AI series. Okay, so this day is really going literally important, you can say. Because of that, today we discuss a little bit about two method of optimization. So especially in the method of optimization, we just discuss little first party like a little bit we discuss. You can say Lagrange optimization method, and secondly like momentum, not at physics momentum, it is like mathematical momentum. So it like somehow similar as a physics and the mathematical part, but yeah, this momentum is like in the mathematics especially we use for this is on identity in the maths, especially in optimization theory about momentum. So yeah, we discussed little bit momentum. I think momentum really matter while you just making a model. I think one of the unique about momentum, just a unique, this is momentum is unique optimization theory. All this particular optimization theory are somehow related to each other. Quasi Newton method, and all the particular methods are related to each other. But when you're just talking about like momentum, it's like entirely different path, or it is like entirely different landscape. Okay, and that's lots of unique about this. You can say momentum. So again, uh, if this particular video is going to productive for you, if you learn something from there, then it's my pleasure. So let's start. Hey, let's come to the first agenda. And in this agenda, we discussed a little bit about optimization method, and this is a really important one. So when you just training a model and just LLM model especially, so that's the important one. So let me try to understand. As you know, I always start with my three magic word to understand any abstract concept. So again, just I pick only two magic word to explain you entire context behind the Lagrange multiplier, especially optimization theory. So if I say, let's suppose you want to you go to the hike. I think you go hike. Uh, let's suppose Manali, Nainital, anywhere in India and anywhere in the world. So when you go to hike and just you climb a hill, okay, when you're climbing a hill, you notice something. This is a particular your goal, and this is something. This is you. I think that one main challenge is if I give you a little bit. If I say little bit about, if I give you the main challenges, you're like okay, you need to just go and achieve that particular goal. You need to move toward the goal, but on specific sets of rule. Okay, sets of rule is here. Like you need to move only straight. Like not at left or right. Something you need to straight. So that's the rule. So I think you need to if you want if you so like you are moving toward your goal, but with the rules, by following rules. Is that particular one you can say is like Lagrange optimization method. Lagrange optimization method is like similar in that real world, right? We have discussed it, this particular one, like real world application. We can say we try to just climb a hill and achieve that milestone, but somehow we need to follow some kinds of the rules. Okay, I think that's important to discuss because rules is important to follow in some specific way when you're just moving toward your milestone or something goal. Similarly, if I say, mm, let's suppose you can say this is a optimal point, this is a gx, and this is a fx, and little bit. Let's suppose this. If you want to move toward the optimal point, I think optimal solution as a graph, like this is a gradient, and the gradient is all about moving toward the optimal point. Gradient descent especially, so you find a direction to move. Okay, so there is a lots of the initially they start with the zigzag method, something zigzag method to move. But if I set a rule, okay, follow this particular you just move in smooth way, not in zigzag way, like something this, only straight forward, you move toward only straight way, so that the gradient is moving straight away. Gradient is all about search algorithm, you can say gradient descent is all about search algorithm. It give a direction to move and just pushing, this is directional push of algorithm of LLM model. But when we're talking about Lagrangian, Lagrange is all about something, it is rule book. Let's suppose why the Lagrangians matter. Because of that, this is really to understand. For example, when you're just trying to understand a little bit about when you're training your model, you have lots of constraint. Constraint means something condition or restriction. So let's little bit about that. We can say you have a lots of constraint. What are constraint are? When you're training a model, you have limited memory. Let's suppose constraint are memory, this memory, bandwidth, GPU power. You have limited GPU power, especially when you're using NVIDIA GPU. And so if you can't afford this particular NVIDIA GPU H100, then you only just keep the particular GPU as a rent as cloud service you for training a model. Okay, that's the basic thing. So if you have some constraint, like you have limited memory, bandwidth, latency, something, GPU power, then what you can do only thing is, you can say is like you need to make a sets of rule. Okay, just train a model, but in such way by looking toward those constraint. Let's suppose you train a model, but let's suppose you have memory like 128 GB. You're using 128 GB memory only for that, for training a model. So when you're training a model, you feed that particular constraint. Okay, just move the gradient is just okay. You train a model, you say that your LLM model just train a model, but look toward this particular rule book. This is a memory, this is my limited memory, and train your model according to it. Just train a model according to it, not exceed 128 GB. So that's the basic thing you can say. Similarly, you can say other lots more thing, but let's suppose if I just say you in like when we in childhood, like we are actually doing assembly, there were few rules and disciplines are something, just go and just stand in a line in a row, something row and columns. So that's the rule and constraint we need to follow. So rules is important for, especially not only for real world, it is all about for computational world, it's all about something technical world also. Is somehow we just try to move and push our gradient, but according to some constraint that our have limitation. Like we have, okay, so we have no any infinite energy and we are just trying to solve a problem, but we have limited energy, right? The reality is something, we have limited energy, and how can we use this particular energy in smart way? That the basic reason you can say. So in that particular one, with the gradient is pushing in direction, but in like on some constraint of rules. That the basic idea behind it. Lagrange. Okay, actually, let me discuss. There is a goal and constraints. You are moving toward goal, but looking toward a constraint. Okay. Let's suppose you want to just crack any examination. It's fine. Just move ahead, but follow the rules. What the proper attitude that needed to just achieve that particular milestone. Okay, let's suppose you need a books and you need a teacher, you have some personal something what you needed, just follow that right way to do particular thing. That's the basic thing. So it's okay, that's, so we can say the goal and constraint actually define the Lagrange optimization method. It's okay. Let me come to discuss a little bit about one more thing, is like how actually it's work. This is important one. So basically initially we need some loss function, either in the form of cross entropy. You know about cross entropy very well. Cross entropy is one of the loss function, and it really helps us to calculate there how much the loss are in between the two basic parameters. your predicted and actual output. So loss function is something like this. So you are right about it. So we need to decide initially. We need to decide object function in the form of loss function. Let's suppose cross entropy, and MSE is one of the loss function, but it is not widely used. But cross entropy is most common one. You can just like many of them using that cross entropy as a loss function instead of that. This is the first choice. Cross entropy is the first choice. So we can say, let's suppose we pick the cross entropy of any LLM prediction or something different. So after this particular cross entropy, just we try to move toward constraint. We need to decide the constraint, what kind of constraint that you just put. Uh, is it something like you can say like memory, bandwidth, latency, or something different? So that's the basic thing you can say what you are going to put. After deciding constraint, you need to just use the Lagrange multiplier, something scalar quantity, which is basically help us to link the objective function and little bit about constraint function. They equate the both ideas. Like Lagrange multiplier, basically Lagrange multiplier help us to equate the both. But it helps us to just equalize this both equivalence, just make equivalence of both. By following the rules, they move according to it. So Lagrange multiplier is responsible. Then apply the equation and find that uh, particular the loss according to it what you want to do, optimal point. So this stupid idea we are discussing, because of that one, not only for uh, this is not only for that we can say uh, optimization. We have a lots of method of optimization. Why we are discussing this? The unique about this particular idea of the Lagrange optimization method is all about something you can say uh, is all about something constraint, rule, regulation, discipline that's similar in our real world. Move your life, move ahead your life, but follow the discipline. That's the basic. Okay, let's suppose you train a model. Sometime model exceed, it is far beyond your cost. Model training is far beyond your cost. How can you just limit this particular cost as particular your uh, equivalence, your particular your investment or something, or more different? So that's the similarity you can just look toward it in that particular Lagrange optimization method. Just work according to it. That's the basic thing you can say. Okay, that's enough for the Lagrange optimization method, and let's move toward the momentum. Hey there. Let's come to agenda number 2, and in this agenda we actually talk about little bit momentum. Momentum is one of the optimization method, and really that unique about momentum is like uh, okay. So we discuss what the unique about momentum. So let's start. When we're talking about momentum, momentum is some as optimization method, which is basically used to optimize the algorithm and increase the learning rate or something efficiency of the learning efficiency. And if you just push the efficiency, if you want to push the accuracy above the 90-95, you need to use that particular method. And this is a particular beautiful method. You can apply this particular method to optimize your algorithm much fast possible. Okay, and which is the cost saving and little bit more about. I can't explain the like what the adjective behind this particular thing. So yeah, okay, that's the basic thing. Uh, momentum is basically again, if I start this momentum, if I want to explain you momentum, so it sounds like physics term momentum. So momentum is something like Newton's second law. In the physics, when we're discussing about the momentum is like something Newton's second law, where we're discussing mass into velocity, especially momentum. But this is a different part of the physics, and now we are discussing in different domain like optimization. And here momentum have on specific identity, and we especially we need to respect that particular identity, and okay, that our goals are. So again, let's come to understand momentum optimization. Just I give a three magic word to explain you like what actually momentum is, and what how actually momentum really helpful for us. So momentum is all about remember, smooth, and acceleration. So it's all about help us to remember and recall all the concepts that actually the model learn. So let's suppose uh, uh, let's suppose this particular graph. So when you just train a model, you need to just move toward the optimal point. So this is optimal point, and let's suppose this particular thing is optimal point like gx, and you are in here like px, and you try to move according to this particular one gx. This particular point is really optimal point, you can say, and when you just try to move this particular point and particular part of the graph, sometime you need to take a big step, sometime you need to take a small step, and sometime take more larger step as compared as our expectation. Sometimes it's difficult to take. So what actually momentum help us to do? Momentum help us to find their optimal point by remembering something. When just it is a iteration process. It iterate one by again and again particular method, and they train itself. They itself store the information in that particular situation. I will try to connect with real world analogy. It really help you to understand much better about what happened inside the momentum. So especially in momentum, let's suppose you are moving in foggy place where you have nothing idea where to move, but you already gone like couple days ago, and you have some specific idea which direction is a suitable direction for move. And when you're taking a just any step, because this is the foggy area and you have nothing idea about what the in the front of you. So when you're taking any step, you use this to a specific parameter to make decision for any such as next step. Let's suppose the first thing is like fresh data, new data. Let's suppose you are moving. Uh, if you're moving A to B, let's suppose A and this is B. If you are moving A to B, you need to look toward their current situation also. This is a fresh data. This is called a fresh data. And little bit about past experiences. What the past experience says, yeah, this particular step is really useful. That accuracy to get right for this particular step is like, I think maybe something like 80%. But what's about current situation? Current situation say that yeah, this is also useful. You can take this particular step. So that's the basic looking toward the past experience as well as uh, new data. Just you make decision. So similarly happen inside their like momentum. So that's the unique idea of momentum. Momentum is not all about it retaining the knowledge, retaining the little bit information from the memory, and storing the information in memory which is useful, which take attention. Okay. So specific, when you just moving to optimal point, you need to make lots more decision, where the flat point, where to take big step, where to take a small step. So this optimal point is not easiest step to just move. So more order, this is the order, this is the like sequential process where you just try to move according to it, and you need to just take a lots of decision around it. So is it required, or is it how much step size, what the basic thing, what the memory, what the byte, lots of information you need to deal with the lots of parameter. So for understanding that particular, for reaching that particular point, you need to just take a decision, and really momentum help us to make decision by past experience. So for gaining a past experience, you need some kinds of training, as you know about it very well. uh, so momentum stores the all information. The gradients work to move toward the entire work of the gradient, quasi Newton methods are moving toward the pushing the directional push to their model in optimal point. But the momentum and something like we discussed a little bit about, you can say, um, lots of method. Momentum is one of method which basically help us to know about little bit something. How can you just move? That's the idea. That's the entire framework, you can say, and understand in that way. So it's not all about like what you moving, where you moving. uh, the all work of pushing your gradient in directional push, give directional push like Newton method. But momentum makes sure that particular step would be like nice step, or bad step or something good step. You can just note according to it, like past experience. So give you three words like remember, smooth, and accurate, accelerate. So in such way, like okay, so when you're taking any decision to, when you take any step to ahead the optimal point, then I think you need to use the two kinds of the information, fresh data as well as past experience. So you need to remember that, you need to retain that particular information that's in your mind, just fetch out that information and take decision what you are going to do. Similarly, that's all about remember. Second is smooth. So momentum ensure that all the particular steps are going to smooth. It guarantees we try to make smooth pathway for moving the optimal point. Let's suppose the gradient is a gradient alone's work in zigzag something path. They follow zigzag something path to reach that optimal point. But when you say the little bit about momentum work in such way like they move toward in optimal point but in different way, in smooth path, reducing all the noise. They know what the noisy points are and they try to reduce the noise. Okay, so that's the basic. They follow smooth path and they try to actually accelerate the more as possible in smoothest path, as compared from gradient descent or slow method, and momentum just increase the acceleration much fast as compared from other methods you are choosing. Okay, so that's all about the momentum, and I think the idea of momentum is really crazy idea. You can't imagine that particular idea is like so that particular thing. So yeah, and next part is like how actually it's work. The okay, so that's the basic one. You can consider this particular how it's work, but in the interesting part of the particular momentum is all about something velocity accumulation. It starts with velocity accumulation. It's so initially just in, I take the analogy, that real world analogy that you can understand, like okay, if I take a decision on the foggy step, we need to just look toward the both domain, the first past experience as well as fresh data. So by this way we take any predictive decision. Okay, yes, so that's the velocity accumulation. First you decide how the step size look like, and by past experience and fresh data. That's the velocity accumulation is. Then after you move toward the damping of oscillation says that something reduce the odd zigzag points, zigzag way to move. So we are not moving toward a zigzag way. We try to make a just smooth path where we just are moving straight forward without any such as a turnover or something left or right. So that's the damping of oscillation. Oscillation refer to something back and forth movement. So we are not just believe in back and forth movements. Momentum says that yeah, we are not believe in that back and forth movement. We just move toward their right direction in straightforward direction without any zigzag weight. So that's the basic idea of damping of oscillation. We oscillate, that oscillation will be damped over there. At the last point is like acceleration. Acceleration is just such a great, you can say that the basic, you can say after the all the reasonable step taking, we take all the reasonable step like velocity accumulation, damping of oscillation, we get at the end of output like acceleration. Acceleration is a crazy like is one of the best way, just I can say you like you got a direction, you have a direction, you have smooth part, you need to only accelerate without any noise. So let's suppose you have no any traffic in your road, what you do, just move fast without any disturbance. So that's the same idea behind the acceleration. So after taking all the reasonable step, we just have all the uh, we have no any traffic inside the road, then we try to move according to it. So that's the basic idea, you can say. So momentum of optimization method, that sound something like okay, we take decision, press, and past experience. It's all about retaining of information. Okay, you retain the information in such way like yeah, we try to retain the information first, and okay, this particular information is like something, if we take decision, okay, i I'm just familiar about that particular steps. Yeah, you can take the, just go to the memory and just look at, is that in a step you just taken before, and you take a decision according to it. That's the basic thing, you can say, idea behind the momentum and optimization method. That's the basic thing. And okay. Okay, again, if this one going to productive for you, if you learn something from there, then it's my pleasure. See you soon.